Let's take a look at our lesson on solving by factoring. But before we get into solving, let's start with a review of just factoring, just a reminder. So I have several tips for you, which you probably remember. This is just a review. The first thing that you're always going to do is look for a greatest common factor, a GCF. If there is one, you need to factor it out first. That should be the first thing that you do. Then after that, you have three options. You may have a two-term. Let's just for fun, we'll just call this 2, 3, and 4. Okay. If you have two terms, remember terms are things separated by plus and minus. Like this has two terms. That's the first term and that's the second term. You know, this has three terms. That's 1, 2, 3 terms. Okay, so that just a reminder what a term is. If there are two terms, once you've factored out your GCF, at this point you can look for difference of squares. Remember, that would be like x squared minus 4. And x squared minus 4 would factor into x plus 2, x minus 2, if you recall that. That's called the difference of squares. So that if you have two terms, that's what you would look for. In a few lessons, we're going to learn another technique for two terms, and that's the sum and difference of cubes. But we're not there yet. That's just kind of coming up in a few lessons. If you have three terms, then you would proceed to do your guess and check, like FOIL, using factoring like FOIL. And then if there are four terms, you want to look at factor by grouping. So it really shouldn't be like a mystery on what to do to factor. Step 1, you factor out your GCF. Step 2, count to see how many terms you have, and depending on the number of terms will depend on which of these techniques that you would do. It is possible that you might come across something that is non-factorable. That's possible. But if it is factorable, it's going to take one of these little techniques that we've talked about. All right, so let's start with the first example up here. We have two terms. We're going to do our greatest common factor first. We look at 16 and an 8. And we know the greatest common factor between those two numbers is an 8. Then we look at x squared and x, and then the greatest common factor would be an x. Now remember, factoring means dividing. And maybe that's why a lot of people don't like factoring. Poor little factoring. Well, I'll have to admit, I would rather multiply than divide, that's for sure. But dividing is important, and so what we're doing is we're dividing this 8x out of both terms. So 16 divided by 8 is 2, and x squared divided by x is x. 8 divided by 8 would be 1, and x divided by x would be 1. And so that's what we're left with. There is nothing else that we can do. That's our, there are two terms, right? We factor out the GCF, and there's no difference of squares, so we're done here. And something I have noticed students doing before is just randomly adding an equals here. Okay, so that's really not a thing. This is called an expression. It's called an expression because there's no equal sign in it. Okay, if there was an equal sign in it, an equal sign means equation. Just some vocab words for us that are really important, because if you have an expression, there's no equal sign in there. You can't just randomly decide, well, I just want to make that equal to 0. That's just not a thing. You're not allowed to insert an equal sign. That would have to come from whoever's giving you the problem. So just a little caution right there. Never ever add an equal sign. Okay. So let's look at we have now a three-termed one. We're going to do this guess and check FOIL thing. Okay, we got three terms, and there's no GCF, so we can't do the look for GCF thing. There isn't any. All right, so if you recall, this needs to multiply to be, here and here. So we know there's an x there and there. We don't really know if it's 4 times 1 So our choice is 4 times 1 or 1 times 4. We don't really know. Or we could do 2 times 2. Those are the options, and we're doing the whole guess and check thing. So those are, I don't know, just for fun, we'll start with a 2 times 2, see if that works. Okay, but it might not work. We might need to try 4 times a 1 or 1 times a 4. When the back sign is positive, if you recall, that means both signs in these, I call these bubbles. I don't know what you want to call it, but I call them bubbles. Both signs inside the bubbles need to be the same, because that's the only way you get a positive 9, right? A negative times a negative is a positive, or a positive times a positive is a positive. So since this second sign is negative, it has to be a negative times a negative. That's the only way they get a negative. And for 9, our choices are, let's see, we could do 1 times 9, or 9 times 1, or 3 times 3. Just because I don't really like big numbers, we're going to try 3 and a 3. Okay, so then we check, right? And really, we know that 2x times 2x is 4x squared, and negative 3 times negative 3 is 9. That's not what we're really checking. What we're checking is the outside and the inside. The outside and the inside have to equal negative 12x when you multiply and add them together, or we've done the wrong, factoring. So we've got outside would be 2x times negative 3, which would be negative 6x. Inside would be negative 3 times 2x, which is negative 6x. And I add these together, and they give me a negative 12x. And so we did do it correctly. Now, I will tell you that you don't really have to write out all the things that I'm writing out. I'm just writing them out so you know when we go through these processes, what should we be thinking about? What should we be doing? And a lot of this you could do in your head, which would be fun, or you can write it out like I just did, whatever you feel comfortable with. So this would be the answer to our factoring. And that was the answer to our first one. Okay, now we'll try one more example, and this is 4 terms. So then we're going to look at factor by grouping, because there's 4 terms there. So right now, what we typically like to do, or what we would do, is group the first 2 together and the last 2 together. But I hope you can see that there's really nothing common here. And it's certainly possible that we may need to reorder those terms. We may need to put them in a different order. They may not have been nice to us, which looks like they weren't very nice to us, and so we're going to have to reorder it. Typically, when you reorder it, a lot of times you would switch the middle 2. Not always. Sometimes you need to deal with this one, the last one, but I think we're going to be okay if we switch the middle 2. Let's just try. So let's rewrite it, switching the middle 2, and see if we have any more luck. Okay, so what we want to do is we want to group these 2 together and these 2 and look for a GCF. I'm just reminding you how to factor by grouping. All right, so we've got the 12 and the 14. GCF would be 12. C to the first and C to the second. GCF would be a C. D to the first, D to the first, it's a D. This is looking much better for us. So remember, factoring is dividing, so 12CD divided by 12CD is 1. 48 divided by 12 is 4. And C squared divided by C is C, and D divided by D is 1. Okay, great, looking good. So let's do GCF on the next one. Let's see, I have a 5 and a 20. My GCF is 5. E to the first, E to the first, it's E. And I don't have a common C. So again, we're going to divide. 5E divided by 5E is 1. 20 divided by 5 is 4. E divided by E is 1. And C divided by 1 is C. So for factor by grouping, what we're really hoping is that these little guys right here, these we'll call them bubbles, that the bubbles are the same. They really need to be the same because we have to go through one more stage of factoring. So the first stage that we did is we factored GCF. That's what we did. We paired them together and factored. The second thing we're going to do is we're going to factor the bubble. We're going to factor the bubble out because I have one here and I have one here. So I'm going to factor those out and bring it up front. Now when I factor that out, I'm dividing it, right? I'm dividing. So when I take this whole first term right here and I divide it by 1 plus 4c, what am I left with? Well, I'm left with the stuff on the outside, 12cd. Again, I'm going to take this whole thing right here. I'm going to divide the 1 plus 4c out. Again, factoring is dividing. And now when I divide the 1 plus 4c out, what am I left with? I'm left with the stuff on the inside. And we would look to see if we could factor this little guy right here, which, you know, we can't. So I'm just going to rewrite it just to clean it up. So I've got 1 plus 4c times 12cd plus 5e. And that would be our factoring for that one. All right, great. Now let's move on to solving. We've got a nice little factoring review, and now we're going to do solving. Okay, so this is really, really important. I'm just going to put a big asterisk here. So for this technique to work, you must set equal to 0. You have to get 0 on one side by itself. If you don't, then it's just not going to help you to factor. And I've seen so many times students try to factor. Like I've seen students try to move the 4 over and then factor an h out, and then what happens? I mean, nothing. You can't do anything. Because we have a special theorem that tells us, we're going to factor this. We're going to have two things. It's 3 terms, so we're going to factor like FOIL. And we have a special theorem that tells us that if I multiply 2 quantities together and get a 0, one of them has to be a 0. That's why it's so important to be equal to 0, because we want to use that theorem. We're not just making up stuff as we go. I know. just so we know, we're not making up stuff as we go. We're using like theorems and stuff. So 15h squared. Now I actually have already factored this, so I'm not going to go through the guessing and checking part. This factors to be 3h minus 1, 5h plus 4. That is the correct. If you want to check your outside inside, you'd have 12h minus 5h, which does give us 7h. So now we're going to use that theorem I was talking about. We're going to say 3h minus 1 is 0. And 5h plus 4 is 0. And so we've got 3h is 1, so h is 1/3. And we've got 5h is negative 4, so h is negative 4/5. Yay. And so there's our first solve by factoring. All right, let's go to this one over here. Notice that my equal sign, I don't have it equal to 0. It should be like warning bells should be going off in your head, like, like lights or warning bells, like no, 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 can't do that. Got to move the 64 over. That's the first thing we do before we try anything. So let's move the 64 over. Now we can, again, 3 terms, no GCF. We're going to factor like FOIL. And again, I have already factored this one. It's r minus 8, r minus 8. So we have that theorem that tells us that if we have 2 things multiplying to get 0, we can set each one equal to 0. One of them has to be 0, right? So we have r minus 8 is 0, or r minus 8 is 0. Interesting, that's the same thing, right? So we have r equals 8. Now we have r equals 8 twice. We don't have to write it twice, but we do have it twice. This is one of those examples of one solution. All right, let's keep moving along. We want to, we're looking at this one right here. We see, or I see there's a greatest common factor there. 16 and then a. And I actually would like to write this in descending order. So with the cubed first and then descending. I just think it'll be easier for us in the long run. So let me rewrite that first. Okay, so now let's factor out 16a. So 48 divided by 16 is 3. A cubed divided by a is a squared. 32 divided by 16 is 2. A squared divided by a is a. And then 16a divided by 16a is 1. Okay, very nice. So what we have here is 3 terms. So we're going to factor like FOIL. I have factored it already. It does turn out to be 3a minus 1 and a plus 1. So now we have 3 things that are being multiplied together to get 0. This poor little 16a, the first thing, that poor little thing is usually forgotten, or not usually, but many times is forgotten by students. Please don't forget that poor little thing. It's an answer also. So I divide the 16 off. 0 divided by 16 is 0. Then I have 3a minus 1 is 0, and a plus 1 is 0. So we have 3a is 1, or a is 1/3. So we've got that. And then I have a is negative 1. Yay! Whew, we're doing great. One more to do. This has 2 terms. I don't see a GCF. 49 and 100 don't really have any numbers in common that I can factor out, so it's 2 terms. So I'm hoping this is difference of squares. If it's not, I can't factor it. Now it's got a subtraction, so difference has to have a subtraction, right? And 49 is a perfect square, x squared is a perfect square, and 100 is a perfect square. So we are in luck. This is perfect squares. So the square root of 49 is 7. The square root of x squared is x. And then we got plus minus in our factoring pattern. Square root of 100 is 10. Great. Now we set each factor equal to 0 and solve. So 7x is negative 10, or x is negative 10/7, and 7x is 10, or x is 10/7. Yay. All right, there we go. There's our lesson on solving by factoring.